Okay, folks, sorry about that, but I had a technical difficulty. And let me share my screen back with you so you can see what we did. We got through chapter 6, okay. Chapter 7 was partial. So I went ahead and posted the partial chapter 7 here, and I'm going to pick back up where we left off before I had technical difficulties. So hopefully we'll be able now to complete chapter 7 without any more difficulty. And again, I'm sorry for the two videos this week, but again, I did have technical difficulties. So chapter 7, this is kind of where we stopped at, where we talk about Taka time. And that Taka time is that German word that the baton that an orchestra director uses to kind of regulate the speed of the music. So the lean production system does not allow for any overproduction because you only want to provide what is needed and no more. And with a stable master schedule is really about looking at, again, how we can levelize the workload that's going to benefit us from a lean manufacturing process. So let's look at controlling now. When we talk about, again, stabilizing the master schedule, the uniform load, and the tachyton, let's look at this thing called controlling flow with Kibana systems over on page 143. And Kibana is that method of production, which is looking at how we move materials in and through the lean production system that produces, that really is driven from the tenet of producing only what is pulled from the customer. And in services type of organization, a Kibana system may be used to pull many types of work, such as paperwork or even pulling in the customers. And they're but a Kibana really is associated mostly with manufacturing capabilities. And again, the purpose of a Kibana system is to single the needs for more parts and to ensure that those parts are readily available and produced in such a time to support subsequent work orders. So really it's about looking at the assembly schedule that we pull from parts from one work center to support another to align itself with the market conditions. Over on figure 7.3, 7.4, you'll find these graphical examples of this particular concept when we're looking at how we're pulling production cards to support one work center and how we use those in transit to go to the next work center as we withdraw that card, so that you see that over on, again, page 144, 145 in figure 7.3 and figure 7.4. But let me come back to here, the Kibana system. Here will give us this formula to which we can use to help us determine in this concept of this Kibana system how many containers of parts that we really need to keep the workflow working appropriately and correctly to ensure, again, that we have, using the pull type mechanism, we're only getting what we need to the system to ensure we're meeting the demands of the customer. So you can see the demand rate equals D, T equals the time for the container to complete the circuit, and to complete that circuit means from the time it comes into it gets loaded, the time it comes into the work center, to the time it's being offloaded at the work center, to the time it goes back out, to it gets reloaded to enter back into the system. And that's really called the entire circuit. And you have C, the container size, or the number of containers that we use. So that's what you see that formula over on page 145. And over on page 146, they give us a good example of how we can use that formula in two work centers. And you look on top of page 146, you see that it starts off with work center B is 2 parts per minute, and a standard container holds 25 parts, and also assume that it takes 100 minutes of lead time for the container to make the complete circuit. So you see how the math is working there as well. But please bear this thought in mind, that the unit of measurement here is paramount. You see 2 parts per minute, and it takes 100 minutes. So if given in the real world situation where we kind of like to mix terms, where we talk about hours and minutes or vice versa, just be mindful that when you're doing these type of calculations that you want to make sure you're using the correct unit of measurement. So if they give you one time in minutes and the next time in hours, just do the conversion again. Make sure you're in the correct unit of measurement. And the whole reason of doing this is to reduce having the correct number of containers. Really is about reducing the lead time, so that again that the lead time that container is going to be needed for that next step in that manufacturing process is going to be there. That's really what it's all about. So the Kibana system really looks at the need for more parts and how we go about signaling that need. It uses these simple cards or signals to control it, and each work center only receives what it needs. Really helps prevent the buildup of any unnecessary inventory while reducing the overall lead time. And certainly it's all about making sure that we're receiving the correct orders and that we're supplying the needs of those orders and fulfilling what the customer wants. And again, you see all that discussion on 144, 145, 146. And you have the figures here as well. So reducing setup time and lot sizes over on page 147, excuse me, really is about how do we determine what the setup time is, and how do we go about reducing that time? Because reducing that time is very important because it increases the available capacity of our manufacturing process. Certainly gives us increased flexibility in that process, as it allows us to meet the schedule changes while reducing inventory. So that's really the reducing the setup time, how strategically important that is to the manufacturing process. Now there's several different types of setups where they may be called as single setups, which is refers to a setup time that is completed in single digit minutes. Single setup, a one-touch setup is also being pursued, which is a setup that indicates that it's set up in less than 1 minute. Then there's other setup types, which may be a two-step process, which includes the first external and then the internal, which are separate. But the internal setup refers to the actions that require the machine to be stopped, whereas the external setup can be done while the machine is operating. Then at the bottom of page 147, it gives us a great example in a hospital environment as they're moving patients from the emergency room to surgery. So they give you that example. Then they give us another example as related to a NASCAR race car and how the pit crew will quickly fuel, change the tires, and clean off the windshield to ensure that the driver is ready to go. And hopefully the goal of that particular setup is to ensure for NASCAR that the race driver is prepared, can go the distance, and actually win the race. Where for surgery, is that the successful outcomes of whatever ailing the patient will be corrected and no adverse effects from that. So reducing setup times is particularly important when we have multiple product models that are being produced by the same work centers. Small lots should be scheduled as we continue to reduce lot sizes, and the goal of a single unit production or lot size is one, which got to be looked at if we're looking at potentially reducing the overall total system cost. Here is an example of a non-lean layout, figure 7.6, a lean layout, and a cellular manufacturing layout that we see on page 149. And this really is an illustration of how a natural effect occurs when we lay out our plant and equipment. And if we're not careful, we can make it encumbered where we're actually losing efficiency and productivity just by the way we're physically laid out. When it comes to how we get our inventory, where our inventory is being placed in the manufacturing process, and how many steps or work centers, they're calling, or work processes. But how many steps a worker has to go through to get the material to the work center so they can actually fix or complete the final assembly. All of this has a potential to increase inefficiency, excuse me, to decrease inefficiency, but by using these concepts, we hopefully will increase efficiency and make ourselves more effective and productive as we use these type of lean thinking as we lay out our manufacturing plant. And in this particular example, this cellular is really about a layout that's involved into a group technology or GT or cellular manufacturing layout. In this particular example, this is where the inventory buffers, which are right next to the machines, so that we can eliminate the parts flow from one station to the next. And as a result of this consequence of the lean thinking is really to trying to evolve towards cellular manufacturing or this GT technology. It's made to reduce lot sizes to a single unit because the inventory on the floor is capital tied up and it takes up space, but we want to have the right amount at the right time to prevent workers from having to continuously go back to the stock rooms. That's really what it's all about. And in this lean manufacturing setup process, preventive maintenance of the equipment is absolutely paramount. Since inventory levels that in production rates and schedules are developed with those concepts in mind, cut to minimal levels, workers must and should be, because we're production oriented in our manufacturing processes, it's really critical to ensure we have everything in place for that worker to maintain the full capacity of that particular line or manufacturing process. And when you have equipment downtime, that has an adverse impact. So a lean system requires the right amount of capacity, the right amount of inventory, the right number of workers, and everything operating on schedule, as scheduled at maximum capacity. And when you're doing preventive maintenance, certainly doing that preventive maintenance, it's got to be scheduled accordingly to minimize the impact. And this is where workers really have to take on a higher level of responsibility in their equipment and workspace. So they really have to own that because they're the ones who's going to operate the machines. They're the ones who know the machines better than anyone else. So they're the ones that we got to listen to ensure that we're taking their voice and helping maintain the equipment to keep it at operating efficiency. How do we go about doing that? Is engaging workers. One of those is through multifunctional, making sure our workers are trained, making sure that they can do multiple things in the workplace and not just get to a point where they're so specialized that that's the only thing that they can do. We really want our workers to be multifunctional, where they can do multiple things to maintain what they think. What they do. So cross-training of workers becomes critical. It certainly is a human resources manager responsibility, but equally important that burden is placed on first-line supervisors, the management team, as well as the workers to recognize that being multifunctional really is in the best long-term interest of the organization. And the side benefit to them is that it makes them more marketable as well, keeps them employable. But equally important when you think about engaging workers, if you were to study the term engagement in today's workplace, you'll find out that it's costing businesses millions and billions of dollars of lost efficiency and lost productivity. And in those studies, it indicates that if you look at the workplace, and this is an approximation of values, but about a third of the workers are fully engaged, which means they understand how they go about creating value for their organization each and every day. They're those workers who, that mission and vision and value statements that you have posted all over your workplace, they understand that. They internalize that. They have rationalized in their head of what they do each and every day and how they create value and support of that mission, vision, and value station. They're the type of workers that all you have to tell them that this is what I need done, then step back out of the way because they're going to go get it done within the boundaries of their autonomy, the rules, the processes, and the procedures that have been established. Then we have the next third, and those workers are typically the ones who typically will do very good work as well, but they're the ones who kind of take a step back and say, well, what's in it for me first? Let me make sure it's going to meet my needs. And then they will typically get engaged. Then you have the bottom third, and again, these are approximation numbers, but this bottom third are those workers that typically where a manager or leader will spend the majority of their time having to deal with, because these are the workers typically are your poor performers who really don't want to be engaged, who really in some cases may not do a thing until they're absolutely threatened with employment. So but you, again, generally speaking, you kind of see that in those thirds. But having workers who are cross-trained, how we go about rewarding those workers as they gain these new skill sets, it certainly enhances their ability to contribute. But equally important, it gives them their buy-in in that decision-making process because they now may come from a worker to actually being a true stakeholder in the organization, which is where we want all of our employees to be, really do. So quality, over on page 150, quality is a tenet that's got to be included into a lean production system, and a lean production system really is designed to expose those areas, identify those areas, identify where the waste is being occurred, making sure that that is identified and fixed at its most lowest levels so that it's permanently fixed. And it's not about covering up or trying to work around an issue, but it's really about attacking the issue, the problem head on, and getting it fixed so that it's never, ever repeated. And that's a continuous improvement process. And that's where a lot of organizations are moving today, because we know quality is paramount in customers and a customer-driven society and economics that we're in today. That as a customer like you, when I buy a product, I certainly expect it to operate the way it's designed. I want it to feel good, look good, but I want it to operate, and I want it to operate for an extended period. I don't want to buy it and have to replace it or have it repaired in a short period of time. So rework, quality defects, certainly recalls, all of that leaves a bad taste in consumers' mouths and really has a potential to make a company lose business. So quality is a main driver when you talk about lean production and lean manufacturing. Now, and as we transition in these lean, as we move more towards a lean manufacturing, lean production systems, or a lean service type process, developing great relationships with our suppliers is also going to be needed as we move forward doing lean concepts. And if you look at over on page 151, 152, you see that some of the features of a type of program that integrates lean productions with good supplier relationships. We see that it's early supplier selection, family of parts sourcing, long-term strategic relationships, and paperwork reduction. All of that is paramount as you're looking at trying to redefine, redesign even your supplier relationships, because changing these supplier relationships is just one more important aspect of creating a lean production system or a lean service-oriented type of system. We got to have great suppliers. We got to have those great relationships, but equally important, we need to do that with our customers as well. So how do we go about implementing some of these lean systems? You see over on page 152, 153, some of those concepts where we, in this example 7.3, table 7.3, waste in the healthcare industry, some of the things that waste is identified, and some of the examples that potentially could be corrected to improve the lean manufacturing process. And then we have over on table 7.4, where we're looking at what are the tenets of lean and some of the techniques and concepts that could be employed to help eliminate that. So it really comes down to having a redesign of our lean thinking or our way of thinking to identify ways to eliminate that waste, to improve our overall effectiveness and efficiency of our manufacturing or our processes, whatever type of business that we're in, to ensure that we are creating value for our customers, creating value for our shareholders, and equally important that in creating that value, hopefully we'll increase our market share as we continue to build upon our distinctive competencies that gives us our competitive advantage and how we can maintain that competitive advantage. And using lean thinking and lean systems concepts, using through these Kaizen events, is a way in which that can be accomplished so that, again, we can maintain and increase our market share. So this concludes chapter 7. Thank you so much for listening, and please go back and look at chapter 6 and the beginning of chapter 7 in that first video. Thank you.